Hello again. Here, this first slide is just some ACT prep questions. If you are interested in going through those, we will go over them in class. I'm not going to actually spend time on the video going through them. We are going to start today with geometric sequences and series. And what that means is we've spent the last couple days on arithmetic, which means you have a common first difference. So you add or subtract the same thing each time. A geometric sequence means you have a common ratio that compares any previous term, or excuse me, any term to the term before it. Okay, so what that looks like, and then in order for it to be geometric, it has to have the same ratio each time. If it doesn't have the same ratio each time, then it's not geometric. So we're just going to look at some examples and decide whether or not they are geometric. So when I said we look at a term and the term previous to it, that means we are looking first, in this case, at 12 and 6. Okay, so we look at the ratio 12 over 6, which is 2. Then we are going to look at the next two, 20 and 12. 20 divided by 12, excuse me, put the wrong number there. 20 divided by 12. Okay, and then we can look at the next two, 20 and 30. So 30 divided by 20. If each of these has the same ratio, meaning it simplifies to the same thing, then it's geometric. As you can see, 12 divided by 6 is 2, 20 divided by 12 is not 2, and 30 divided by 20 is not 2. So this one is not geometric. The next one, if we compare, we have 256, 64, 16, 4, and 1. If we compare a term to the term previous to it, we would have, these two would be 64 over 256. Okay, the next two would be 16 divided by 64. The next two would be 4 divided by 16, 1 divided by 4. And if all of these simplify to the same thing, then it's geometric. And in fact, they do. All of these ratios simplify to 1/4. So yes, this one is geometric. And its common ratio is 1/4. Some of you might have looked at that and said, oh, I can see I'm dividing by 4 each time. Well, dividing by 4 is the same thing as multiplying by 1/4. So our common ratio is not divided by 4, it's multiplying by 1/4. So if we take a look at these next few, we can decide whether or not they are geometric. And then if they are geometric, decide what the common ratio is. So if you look on number 1, 9 divided by 27 is 1/3. 3 divided by 9 is 1/3. 1 divided by 3 is 1/3. So yes, this is in fact geometric. And the common ratio is 1/3. Okay. If you look at the next one, you have 6 over 2, which is 3. 24 over 6, which is most definitely not 3, so that is not geometric because it is not constant. If you look at the next one, okay, you have 2 over -1, -4 over 2, 8 over -4. If you simplify all of those, they all simplify to -2, which means it is geometric, and you have a common ratio of -2. So you're multiplying by -2 each time. Okay, so the next thing that we are going to do, much like we did with arithmetic sequences, we are going to write a rule for a geometric sequence. And again, it is formula based. In this case, it is a sub n equals a sub 1 times r to the n minus 1. Something to note is that when you finalize these rules, you do not want to multiply a sub 1, which is your coefficient, by r, which is your base. Those do not get multiplied together. Kids often make that mistake. And then just like with when we did arithmetic, you will have a sub n and n will be part of your rule, and there will be a number value for a sub 1 and r. So let's look at a couple of these. Okay, so it says, first of all, we're going to write the rule. Okay, so our rule is a sub n, here's our formula, is a sub 1 r to the n minus 1. Okay, so we need to know what a sub 1 is, and we need to know what r is, basically, in order to write our rule. Well, a sub 1, so our rule is a sub n. A sub 1 is 5, because that's the first term in the sequence. And then our r, if you notice, it is times 3 every time. So we are going to have 5. We're going to put our ratio, our ratio from one term to the next in parentheses to the n minus 1. And again, do not multiply 5 times 3 and get 15 to the n minus 1. Order of operations says when we do this and actually calculate it out, that n minus 1 is an exponent, so you have to do that first, and then you can multiply. So the second part of this was to find a sub 8. So a sub 8 is 5 times 3 to the 8 minus 1. Okay, so that'd be 3 to the 7th power times 5. And if we put that into our calculator, we get 10,935. Okay, so here is our rule, and a sub 8 is 10,935. Okay, if you look at letter B, okay, we need to have two things. We need to know what a sub 1 is. Well, that's 88, that's easy. R, if you pick two terms in our sequence, so it's negative 44 over 88, or you could do 22 over 44, simplifies to negative 1/2. So, and that's basically like dividing by negative 2, I guess. So if we were going to write our rule, we'd have a sub n equals our first term, which is 88. In parentheses, we are going to put our ratio to the n minus 1. Then if we want to find a sub 8, we'd say 88 to the negative 1/2 to the 8 minus 1, which is to the 7th power. If we put that into our calculator, we would get negative 0.6875. Okay, so this is, again, just the same thing, except in this case it's asking for a sub 9, it looks like. So we know a sub n is our first term, which is 3. Our ratio, it's multiplied times 5 each time to the n minus 1. Can we just do that one? Nope. So there's our rule. If I want to know what the 9th term is, I'm going to take 3, take 5, raise it to the 8th power, because that's n minus 1. And again, we need to do the exponent first. And we should get 1,171,875. Okay, now we're going to do kind of like what we did with the arithmetic, where now instead of giving you the sequence, I'm going to tell you a specific term in that sequence and give you the value of r. And again, first you're going to have to find a sub 1, and then you can write the rule. So again, here we have a sub n equals a sub 1 times r to the n minus 1. So the values that we know that n equals 4, because it says a sub 4 equals 12. We know that our a sub n is 12, so we're going to have 12. We don't know what a sub 1 is. We do know that r, it tells us r equals 2. And we're looking at the 4th term, so we're going to have 4 minus 1. So I have 12 equals a sub 1. It tells us that r equals 2, so I should put that in there. Sorry. This right here should be a 2. And 2 to the 4 minus 1, that's 2 to the 3rd power, which is 8. In order to find a sub 1, I just divide 8 on both sides, and I get that a sub 1 equals 3/2 if we simplify that out. So our rule is a sub n equals a sub 1, which is what we just figured out, 3/2, times r, which is 2 to the n minus 1. Again, a sub n and n minus 1 are going to be part of the rule. So here's another example similar to that. We're just going to try the same thing again. We know that a sub n is negative 96. We don't know what a sub 1 is. We know that r is negative 2. And we're looking at the sixth term, so we're going to have 6 minus 1. So we have negative 96 equals a sub 1 times negative 2 to the 6 minus 1, which is 5, which is the fifth power, is negative 32. So we're going to divide both sides by negative 32. And we get that a sub 1 equals 3. Once we have our a sub 1, then we're going to write our rule. A sub n equals 3 times our ratio, which is negative 2 to the n minus 1. Then we get into finding the sum of a finite geometric series, which it says here you can just use your calculator to find that. And we know how to do that. You can go ahead and practice putting that into your calculator. Again, it's that sum button under math. And if you put this in correctly, you should get 118,096. So go ahead and take a minute, put it into your calculator, and practice to make sure that you are doing it correctly. Same thing on the last one. I'll just tell you what these answers are so you can take a few minutes if you want and you can put it into your calculator. This one should be 97,656. The second one is negative 8,190. And the last one is negative 31.75. All right, good luck.